The fisherman fish catch is according to a Poisson process with a rate of 0.6 per hour. The fisherman will continue to fish for 2 hours. At the end of the time, if he has caught at least one fish, so one fish or more, he stops. Otherwise, he continues to fish until he catches at least one fish. So he's really determined. What is the probability that he continue for more than 2 hours? So if we know that the rate lambda is 0.6, meaning we can just plug it into the formula where p of x equal k, so the number of fishes you catch is k up to t is e to the power of lambda multiplied by t, and all of that multiplied by lambda multiplied by t to the power of k, so the amount of fishes we catch, and divided by k factorial. So now we just plug our actual numbers. So here t equal 2, and we can easily deduct the following answer. So here is e to the power of 0.6, which is lambda, multiplied by 2, which is 2 hours. And please pay attention that the rate is 0.6 per hour. This is why I could multiply the 2 hours by lambda. So e to the power of minus 0.6 multiplied by 2, and all of that multiplied by 0.6 multiplied by 2 to the power of 0, which is 1, and all of the divided by 0 factorial, which is also 1. And I just put the numbers in. It's e to the power of minus 1.2, which is approximately 0.3. So 0.33012. And now for the second question, what is the probability that the total time he spends fishing is between 2 and 5 hours? Now it's really easy to know that. We know we want both probability that x equals 0 when t equals 2, and x is greater or equal to 1 when t equals 5. So it's greater or equal to where t equals 1. So we look at this as two steps. First of all, let's calculate the probability that x equals 2 in the first 2 hours. Then, because it's memoryless, we can just multiply by the probability that x will be greater or equal to 1 in the next 3 hours. So the first step is this one. We look, okay, what is the probability that x equals 0 in the first 2 hours? So we just found that in the first section. And then we multiply that by 1 minus the probability that x will equal to 0 in the next 3 hours, meaning all the probability that x will be greater or equal to 1 in the next 3 hours. So this is the probability that we just found, and here is the probability that x will be equal to 0 in the next 3 hours. So it's e to the power of negative 1.8, and now you just plug it into the formula and you get 0.2514. And now, what is the expected total time he spends fishing if he knows, if it is known that he was already been fishing for 4 hours? So this is really easy because it's memoryless. So the expected time, given that we know the history, it does not really change the actual. It does not change anything about the present. So the expected time will be the same, which is 1 divided by lambda, which is 5 divided by 3 hours. Okay, so 1 hour and 2/3, like 1 hour 40 something. So this is the answer, and I see now that there is this section that I did not look at. What is the expected number of fish is catched? So for this, we know there is two options. Either he catch one fish, okay, when he waits more than 2 hours, or he catches the average amount of fish in 1 hour. So I will do this video, I will stop, and I will also add the next section for this question. And what is the expected number of fish he catches total? So this we will need to split into two parts. So first of all will be the part that what happened when t is less or equal to 2, so when he wait only for 2 hours. And then we will need to look at what the probability is when, what happened when he wait more than 2 hours. So we'll split it into two sections. First of all, the probability that he waits up to 2 hours, so the number of fishes he catches up until then, which is approximately 1.2, because he catches 0.6 fishes per hour, he waits for 2 hours, then he catches 1.2 fishes in the first 2 hours. Okay, so this is easy. But what is the probability that he is there for 2 hours? It's what we found in the first section, but 1 minus that. So 1 minus e to the power of 1.2. And this is the expected times the probability that if you wait up to 2 hours, the amount of fishes you catch. Now we'll need to look at what happened when he waits more than 2 hours. We know that if he waits more than 2 hours, he only catch one fish, but he will catch one probably for sure. So 1 minus the probability he wait more than 2 hours. So this is the probability he waits more than 2 hours. And so it's 1 minus e to the power of negative 1.2 multiplied by 1, because he gets only one fish. So now I just plug it into the formula and I get 1.34. So again, what I did was looking at the conditional probability, meaning I split this probability, so the amount of fish he catch, so like this, and looking at that like that, e of x given that t equal to plus e given that x is bigger than 2. And since we know he at least wait until 2 hours, so it's either 2 hours or more than 2 hours, I can split it and discover all our space. And this we just found, it's really easy, was 1.2 fishes. Okay, multiplied by the probability. So I forgot to add this, that's t equal to, and this by the probability that t is greater or equal to 2, is, sorry, greater than 2. And it is also greater than, so this is 1.2 fishes, and this probability t will equal to 2 is, the t will equal to 2, what is the probability to continue for more than 2 hours? So it's 1 minus that. The probability t will exactly equal to 2, and this is the probability will continue for more than 2 hours, which is this one. So it's 0.3 approximately, and you just plug it into the formula. It's really easy. So guys, hope you like this video. Please like and subscribe. I will really appreciate it. Until next time, I'm out.